Hey guys, it's Mr. Haas here, and I know you've been learning about unicellular and multicellular organisms with your teachers in science in class. And hopefully you just got done watching the short video about the difference between the two. So let me just clarify a little bit. Unicellular and multicellular organisms. A unicellular organism is usually really tiny. The prefix uni, meaning one, implies it has one cell. But the coolest thing about it is, even though it's only one cell, it still does everything that a multicellular organism can do. So people would be multicellular. We're made of more than one. Cells are super tiny. And if there was a cell laying on the ground, like on the table, you probably wouldn't be able to see it on its own. So when we talk about uni and multicellular, they're still both living organisms. They are living things. All right. If you had one individual unicellular organism, we'd probably need about the 400 time magnification to really see it decently. So what happens is sometimes unicellular organisms, let's use algae for example. Man, you can see algae when it's in your pool. But what you want to remember is that if you have unicellular organisms, if you have just one of them, you're not going to be able to see without a microscope. But if you have a million and a billion of them together, then you can start to see it. It's just like grains of sand on the beach. If we were to hold up one little tiny grain of sand, it'd be very hard to see. But when you get enough of those grains of sand, you have sand that you can actually put your hand in and feel and see and walk on. And that's kind of how unicellular organisms are. So again, unicellular and multicellular organisms are both living. They eat, they breathe, they reproduce, they move around, they do some sort of breathing. They're alive. So even though it's super tiny, it is just as alive as you are. It might breathe differently, it might move differently, but again, it is a living thing. It is just as alive as you are. So we've been using our microscopes in class here, and the one thing I want to talk to you about, because you're going to be starting your project this week, and the one thing I want to talk to you about is on a slide and what we use a microscope for. So usually we use a microscope. We can definitely use it to see unicellular organisms, those organisms that are made of one cell. Now there are no slides that I have that are just one unicellular organism. So there are some slides that have a bunch of unicellular organisms in them, and you can tell because they're kind of separate. They're not really touching. They might be overlaying on each other, but they're not connected together as one big structure. So that's the one way to really tell when you're looking under the microscope. They're kind of going to be like if you spread out a bunch of pencils on a table, they're all going to be spread out, and if each pencil is a unicellular organism, that's how it would look under the microscope. A multicellular organism, which you can look at under a microscope, you can look at a small part of them. When you look at that, you might see the individual cells, but they'll kind of be put together almost like bricks on a wall. They're all touching, they'll be really organized, and that is one way to know that it is multicellular. Okay? So it's going to be a little bit of a challenge as you're using your microscopes this week to really look at the difference between unicellular and multicellular, but those are some of the clues that you're going to come across when you're trying to figure out what it is that you are looking at. So again, just remember, there's not going to be anything that you look at that's just like one individual unicellular organism. There might be 20 or 30 individual unicellular organisms, all the same kind, on a slide. And if it's multicellular, then you're definitely only going to have a small part of it. Now, let's say you wanted to look at yourself under the microscope. You won't be able to do that because with these microscopes, what we've talked about is when we turn them on and the light comes up, the light has to be able to pass through the object. So you're not looking at an entire multicellular organism under the microscope. You are simply looking at a piece of it. Now, if we were able to get a piece of your skin, a real thin piece, like if it got pulled off or something, we could put that under the microscope, or a fly's wing. But you wouldn't be able to put a whole fly because they're not thin enough for the light to travel through, and it would just be a dark blur. So hopefully this helps you this week. You do have one assignment after this, and that is to go and do the virtual microscope, which is pretty neat. Read the tutorial, okay? Read the directions. It'll tell you how to do it. I tried without reading the directions, and it was difficult. And then I went back and I read them, and I was like, oh, okay, that's how you do it. So don't get frustrated with it, but it's pretty neat because it's almost like you're using ours. It's a little bit different microscope, so you'll have to learn a little bit about the type of microscope that they're using, but it's pretty similar. They have 4 objectives, we have 3. They have 2 eyepieces on the virtual one, we only have 1. But I think you guys are bright enough to figure it out. And again, you read the directions and follow the little checklist that is on the actual website. And if you have a hard time uploading, or you don't have to download it, it's just a website, but I don't know how it's going to show up in your Chromebook. Mine told me I needed a Flash player, so I just clicked to download and it just did it. So yours should too. If that doesn't work, let me know, and I will adjust it and see if I can find another one. But I'm hoping that it works on your laptop. So enjoy it. I look forward to seeing you this week. Make sure you come to school so we can use these awesome microscopes to do our STEM project for the next few weeks. All right? Have a great day.